All right. So we are looking at number 3 there. Let's see if I can make this full screen. I know I can. There it goes. Ooh, even more work. All right. You probably can't see everything now, so that's right. Well, we'll figure it out. So let's see. Particle A moves along a horizontal line. I'm going to read it off. So particle A moves along a horizontal line with the velocity v sub a of t, where v sub a of t is a positive continuous function of t. The time t is measured in seconds. The velocity is measured in centimeters per second. The velocity v sub a of t of the particle at selected times is given in the table below. Woo! Table. A. Use the data in the table to approximate the distance traveled by particle A over the interval 0 to 10 seconds by using a right-Riemann sum with 4 subintervals. Show the computations that lead to your answer and indicate units of measure. So as we're looking at that, it's not asking us to interpret the answer because it's telling you what the interpretation is. So we just have to do the calculation. So here's our first interval from 0 to 2. So we're doing a right-Riemann sum. So let's see, of these two heights, I'm going to use 6.8 because that's on the right. So do 6.8 times 2 plus, let's go to the next interval from 2 to 5. Well, on this one, 7.4 is the right one. So we'll do 7.4 times the width of the interval, which is 5. 3. Good. Again, I make that mistake still sometimes. So I want to try to make sure I emphasize that, because if I make the mistake, like you all probably won't because you're all more competent than I am, but just in case you're right where I am, I want to make sure I point it out. All right, next interval, boom. So again, 15.6 is on the right, plus 15.6 times 2 plus the last interval. We're going to use 24.89 times 3. I don't know why I changed my notation there. I just randomly did. Rip. Okay. So go for it. You're finding the area under velocity. Yeah, so one of the things we did at the end of class, and I think it was part number 2, part B, was what do we have and what do we want? The reason we're doing that is we have velocity. We want distance. In order to get distance from velocity, we have to do an integral. But because we don't have a function that we don't have like a equation for the function here, we're just going to use Riemann sums to approximate the integral. Thank you for that question. That's good. All right. Let's finish writing those down. All right, I'm going to do the calculation. Do you want me to do it all at once or do each piece individually? Cool beans. Times 2 plus 7.4 times 3 plus 15.6 times 2 plus 24.9 times 3. And then I get from that 141.7 centimeters. Yeah. No, Not in this one, because they gave you only to 1 decimal point and you weren't doing anything else that would create more decimal places. So you don't have to write 0.700. And if it is 0.700 is like the answer, you can leave off the other ones. But it's, if you're like, oh my God, I might mess it up, you can just put them on. It's fine. Like we totally could just go and put the 00 on there. Like if it makes you feel better, and maybe it's just a good like thing to do, just throw 00 in there. That's fine. That's acceptable. This is probably, again, this whole intro sheet that we're doing, the front and the back, like 1 through 3, A and B. These are all, in theory, no calculator problems. Like you could do this by hand. Like it's not terrible to be done by hand. It's kind of annoying. It's kind of a pain in the butt, but it's within the realm of possibility. Like you just do each one by hand, add them up, boom, done. And when they do something like that, they're not gonna try to make it wild and crazy on you. Like, you know how decimals work. Does that help? Sweet. Thanks for asking that. All right. Let's see. Let's go back and double check to make sure that we answered everything. Write Riemann sum with 4 subintervals. Totally did. Oh, cool beans. Show the computations that lead to your answer. We did that. Indicate units of measure. All right, so we showed our computations. Here's our answer, and we indicated units. So going back and checked everything, we're good to go. Sweet. Do part B. Oh, that's a good question. Let's go back and check that. So if we did a left Riemann sum for this first interval, this number would have been 1.7. The second interval, this would be 6.8, 7.4, 15.6. Yeah, so that's all it is. And just left to right means on the interval, which output is on the right, which output is on the left. And if they want you to do a midpoint, kind of like we looked at the other day, when you have a bigger table like this, they're probably going to ask you to do like a midpoint, because they're not going to ask you to do like 6 or 7 intervals. That's kind of intense and unnecessary. So they're more likely to ask you to do like the midpoint like we did yesterday. So like 1, 2, 3. Sound good? Cool beans. All right, let's hit this one up, see what's cracking. All right, so particle B moves along the same line with acceleration a sub b of t equals 2t minus 7 centimeters per second squared. At time t equals 1, the velocity of particle B is 13 centimeters per second. Which particle is traveling faster at time equals 5? Explain your answer. Okay, so let's start off with what do we have and what do we want? We have acceleration and initial velocity. We want velocity at t equals 5. As we do start getting into more things that are a little more free response as we practice those different things, it may be helpful to just say, what do I have? What do I want? And because that can kind of help determine what we're doing and where we want to go. So let's see, we have acceleration, I want velocity. So it probably means I'm going to do an integral. Now I know my initial position or my initial velocity of particle B. And by the way, for the record, I already know what the velocity of particle A is. It's 7.4. So I want to figure out what it is at t equals 5. Now I'm actually given an equation here for the acceleration. So it means I could probably actually take the integral of that. Oh, it's just on my screen. What is that? Oh, it's just a mark. No worries. Okay, so what we can do, let's set up the integral. There's a little mark on my screen, and I wasn't sure if it was like a crack in my screen or anything, and it's not. It's just some mark I have in mind. No worries. So what we're going to do is we're going to do the integral from 1 to 5 of a of b, a sub b of t, dt. We'll do 13 plus this. All right, so let me explain what I wrote down. This part right here, that's the initial velocity of particle B. What this part is, the integral, what that does, that gives me the change in velocity over the interval 1 to 5. All right, by integrating acceleration, it gives me a change in velocity. So again, to just hit that again, initial velocity, this is the change in acceleration. So that's a way we can, that's how we can figure this out. Now we physically can go do this. And just for a nice little refresher, let's do that. So we have to do the integral, the antiderivative of this up here. So the antiderivative of that is going to give us t squared minus 7t from 1 to 5. So evaluating that, I get 25 minus 35 minus 1 minus 7. Does that make sense? Does that check? Let's see. Plug in 5 to this, 25. Plug in 5 to that, negative 35. 1 to this gives me 1. 1 to this gives me negative 7. I think I'm good. It is, but it's just kind of in front of it. I'm gonna add it later. So like right now I'm doing 13 plus whatever happens over here. That's a plus. That's why I hook my t's so that my t's and my pluses look different. Also, I kind of didn't plan out how I was going to write that. So that was kind of a rip. So apologies. This is totally 13 plus all of that. All right, so we have this. So let's finish doing this one. So I get negative 10 minus negative 6, so plus 6, which gives me negative 4. Which means I get 13 plus negative 4, which gives me v of b 5 is 9. Now, if I can compare these two, compare that and that, which one's traveling faster? B. And then and I'm not gonna write this part down because I ran out of room on my screen. So, but I'll let you write that down. So at this point, the only thing I haven't done is explain my answer. you can explain your answer and basically just go and tell me that particle B is traveling faster because it has a greater positive velocity than A does. All right. Now, if these are both negative, okay, cool beans. Anyways, if they were both negative, the larger negative number would be moving faster. So it's important to kind of keep that in mind. All right. And for that record, if this came out at -9 and particle A was still 7.4, particle B, if it was negative, would still be moving faster. It's just moving faster in a different direction. So that's something that as we play around with position, velocity, acceleration a little bit more in this kind of free response environment, we just have to kind of be thought, oh, and realize I'm not where I thought it was. We just have to be careful and thoughtful about what we've done, what we're doing, and what we need. All righty. What questions, other questions you have about this so far? Yeah, there's the good old rumble of thunder. Haven't heard that in a while. Yeah, can I scroll back to A? Absolutely. I'll be right back. I'll be right back, virtual folks. I'm just going to pass some stuff out. So there's 6 problems on here, each with about 4 words, 3 to 4 parts. Let me come back here so you can see me. So now the rest of today, tomorrow, probably today's Tuesday. Yeah, probably Thursday as well. We'll be working on this, pack. Working on this packet. So I guess that's what I have for you.